I said this morning I wasn't going to say thanks, but I'm going to take this moment to say thank you to one person who's my Stanford colleague, Roy P., who's not here today. But Roy helped me really to think through what this conference might look like, and even more importantly than that, told me that the person that I really ought to talk to if I wanted to understand this world was Jeremy Roschelle. And so now I'm going to introduce Jeremy, who is the, sorry, I turned my paper over, who's the director of the Center for Technology and Learning at SRI International. And if we've just, he's a person who does research on how innovation in classrooms actually affects student learning. He's looked at some of the tools and resources you've seen today and at others, has developed some himself. And I think if you think of the previous session as speed dating, you can think of Jeremy as the relationship counselor. If you're actually thinking of hooking up with any of these people, talk to Jeremy first.
Thanks very much for that introduction. We're at the time in the afternoon where I thought we better not just do more PowerPoint slides, so I'm trying something new, which is a Prezi presentation. And I'm going to be talking some about the research perspective that we have on the area that we're talking about today. It's wonderful to have everyone gathered here pulling together all these different perspectives. Oops, we're not ready for that yet. So I just want to say a brief word about SRI International. How many of you have heard of SRI? Well, that's terrific. We're nearby, bicycle ride away. We do a lot of work for the National Science Foundation, U.S. Department of Ed in the area of technology and learning. We helped write the National Educational Technology Plan. We're now working on an evidence framework for educational technology. How should we judge if technology is usable? We're also doing a lot of evaluation research. The Gates Next Generation Learning Challenges. We're evaluating the Khan Academy. It's been much talked about. Very nice set of talks, by the way, at cyberlearning.sri.com. And if you have an iPhone, brand new iPhone 4S, that thing you talk to in it called Siri, that's an SRI invention. Okay, so how can technology help us? Well, oops, what if it can't? And I can't come to Stanford and give a talk without referring to Larry Cuban's book on the topic, famous book, Oversold and Underused, documenting the promises made on behalf of technology and how infrequently they pay off. And we were part of conducting a very large study, $10 million study for the U.S. Department of Ed. The effectiveness of reading and math software products, this was a few years ago. The graph in the middle that you see there is the effect of algebra products on an algebra exam, and they're all negative, well, except for one. It's a little bit positive. And in fact, this is a current issue today. You see it in the New York Times frequently. Are we inflating the software report card? Are companies promising too much and not presenting the research on effectiveness? So I want to think with you a little bit about that today. But I have to say I'm not inherently a pessimist. And so I think maybe what's going on is some of the metaphors we use for thinking about technology in schools are too limiting. I think we too often think, is technology a silver bullet? I'm going to put it in there, whoa, kids are going to start learning. Or is it a pill? And, well, I just have to figure out which color pill works best in my classroom, but once I drop that pill in, wow, learning's going to happen. Or is it magic? And this kind of magical thinking is everywhere. No surprise that Las Vegas is gambling. This is from Education Week. They are going to buy iPads, drop them in the schools, the pill metaphor, and they hope it's going to boost test scores. We see this over and over again when we evaluate technology in schools. If you've got a budget, here's my one piece of advice, takeaway advice. If you've got a budget of $100,000, first of all, congratulate yourself for technology. Don't spend $100,000 on technology, right? Spend a goodly chunk of that on content and on teachers, and pulling that together. So I like this cartoon. Where can I find the key to algebra success? And you know where the drunk looks for his keys. He looks under the light. And, well, he's got an iPhone there, so he's looking under the light with the iPhone. But does it really matter which kind of technology he's looking under the same circle with? He's never going to find it. His keys aren't under that light. Right? And so what I want to do a little bit today is to make sure we're casting the beam broadly enough, and we're not looking too narrowly for the kind of solution we're looking for. And here's an overview of the talk. I want to cast a little bit of a beam on how do people learn. I want to talk a little bit about what's really important in middle school mathematics, and share one of our studies about what works in schools, and I'll draw some conclusions that I'll suggest to you. And my perspective really comes from research. There's been a lot of research done in math with technology. I list Jim Caput 1992 as a useful benchmark. It's still a wonderful paper, chapter to read. You can find it by going to scholar.google.com and typing in Caput 1992. So there's at least 2 decades of research on technology and mathematics education that we can build on. This isn't all that new, and we do know a lot. So how do people learn? Here's a famous book on the topic from the National Academies, and it's a worthwhile read. Of course, I can't explain everything in the book in the short time available here, but I want to draw a couple contrasts. Again, are we thinking broadly enough? And so one thing I think is really important is what's our core metaphor for knowledge? And I worry that too often we think of knowledge as bricks, and we're going to pile up those bricks one at a time. If a kid's missing something, we're going to find the brick they're not so good at, and we're going to fix that brick, and then we're going to keep building the wall higher. And when I think of this metaphor, the Pink Floyd song kind of comes to mind. Like, we don't want no, right? On the right, I have a picture I got off of a website that's analyzing mathematics knowledge in middle school and algebra, and trying to show the connections. And look how that looks. That doesn't look like individual bricks. Knowledge looks like webs and clusters, and there's more important things and less important things. And it's not how they pile up on each other, but how they're connected that matters. I think this is very fundamental. We have to really have an image of what the knowledge is we're trying to build if we're going to help kids get it. And so we ought to be questioning those metaphors. I hear too much focus when I hear about technology and algebra on individualization. And I just want to point out that kids learn really well when they collaborate. And there's a really rich tradition of collaborative learning. In fact, the top cited journal today in education and technology, it's in purple, it's a little hard to see, it's the International Journal of Computer-Supported Collaborative Learning. So collaboration and collaborating to share meaning is really an important aspect of learning. And I show a picture there from the kind of technologies kids use today. When my kids use technology, they don't use it all because they want to be alone and individual. They like doing the we. They like doing stuff together. So let's make sure we're not narrowing our beam to individual kids in isolated boxes, all going at their own pace in complete isolation from kids who can help them. We know that the best way to learn something is to teach somebody. And collaboration draws on that. It gets kids teaching each other. Technology can be used very successfully this way. Another point of broadening the sphere, and we saw some of this in the demos today, so this makes this part of this easier. I often hear about learning styles, and technology is going to find the right learning style for you. Maybe you're a graphic learner, so we'll give you all graphics. Maybe you're a story-based learner, so we'll give you all stories. This is a framework I like to use, and what research shows is that learning style stuff doesn't play out all that well. It's kind of hard to find results where matching a kid's type of learning to a resource improves learning. But what does pay off in big ways is forming connections among these different representations and making sure they're all available. And so I like to think about informal and formal representations in middle school math, where a story is informal. I like to think about graphical and linguistic. And how do we form those connections? So graphical and linguistic, that's like, in the formal side, that's like taking the equation, which is more linguistic, and the graph and connecting it. But that's not enough for kids to learn. We also need those connections to less formal things about the mathematics, about the same mathematics. Stories, like that story we saw earlier of the car going to the person going to the store, and it was from the Key Curriculum Press thing. Does the story and the graph, are they telling the same story? And the simulation that went with that. So let's think about connections and linking representations, not just representations in isolation. That's a little bit on how people learn in broadening the light here. I'm zooming back out, and now I want to talk a little bit about what's important in middle school math. Well, algebra is important, so it's said, And I just think it's worth taking a bit of a historical perspective. Not that I don't like algebra as much as the next person. But if you go back 100 years ago, only 2% of the population learned algebra. We've come a long way. And we didn't do it with technology. Somehow, I don't know if 70% is actually the right number, but if you went back 100 years ago, the idea that every kid could learn algebra by 8th grade would have been unimaginable to people. And we've got to ask ourselves, 50 years from now, will people say we asked the right question? Because things change a lot. It seems very hard when you're close to change, but when you step back, education can change a lot. And there is a scholarly debate, I think echoes of it are in the room today, about whether it's worth pushing kids so hard to universally learn algebra in 8th grade. Is it really worth it? And suppose we're at 70% now. I think in California, about a third of kids get passing in 8th grade algebra, and 2/3 don't. Is it worth putting our laser focus so much on algebra by 8th grade, or bust? And I want to suggest that there's an alternative that is very well researched and absolutely at the heart of the Common Core standards, and it's not fractions, which is, people don't talk about algebra, they talk about fractions. Those seem like the only two things we can talk about in math. It's proportional reasoning, which is absolutely at the heart of what's difficult and important for kids in middle school math. So what's proportional reasoning? In geometry, it's similarity. We saw a great demonstration of similarity this morning with the triangles under the light. In number, it's the concept of ratio. It's about proportional reasoning. In data, it's often the line of best fit. We saw some data analysis earlier today. And rate and linear function are about proportionality on the algebraic side. Now, the important reason I bring this up is because when you have that brick in the wall kind of picture, middle school math looks like a whole pile of isolated little standards, and you're trying to fill them all in. But if you take proportional reasoning as the lens, you see how they're all really connected. And so here's a classic slope triangle. Many of you are math instructors, I know, so you'll know what I mean. I just want you to think for a second about how connected our understanding needs to be to make sense of what's going on there. So we're calculating rise over run. And what are we forming? It's a ratio, the ratio of rise to run. So we need ratio. Well, why is it that we can make this slope triangle bigger or smaller, and we can place it anywhere on that line? Well, that's because of similarity. It's because all those triangles are similar, so that the ratio of the height to the distance, the width, is always going to be a constant ratio. Oh, so we're using similarity and ratio. And of course, it has to be linear for that to work. So that picture needs to pull together all those different aspects of mathematics. And I think if we could do that well, we'd be doing a lot for our middle school children all throughout California. That would be a success, and they'd really be much more ready to move on to algebra when they're ready. And my last point for this keynote is I want to talk a little bit about what we've been learning through all our studies at SRI about what really works in schools. And it's a bit of a return to the metaphor problem earlier. What we find pretty universally is just putting technology in as an isolated element never works. We don't have many successes of that. So what does work? And I'm going to share one study I've been very closely involved in over many years. It's with a piece of software called SimCalc that comes from the University of Massachusetts. I'm not going to show SimCalc, but it's in the vein of dynamic representations like the ones you saw with the dynamic statistics and the dynamic geometry. And there's lots of research. All our research is published at math.sri.com, so you can see it there. And what I think was important about this set of studies we did isn't the technology, but how much work was put into integrating technology, curriculum, and teacher professional development into a very tightly coupled unit that teachers and students could really successfully implement across a large number of settings. So I show there managing the soccer team. That's the curriculum workbook that's connected to the software. The software itself connects the representations that I talked about in the learning theory section. So it has, in fact, we can zoom in a little bit, and you can see that. We use storytelling about motion. We have motion phenomena at the center of this unit. This is a unit about rate and proportionality. And we connect the algebra, tables, graphs, and narratives all around the phenomena of motion. And teacher professional development is linked to this. So what happens when you do that integration? That's the study. Actually, really now it's quite a long series of studies that we've done over time. And these studies were all randomized experiments. Well, not all of them, but the core ones were randomized experiments. And the way we did that is we would ask a pool of schools, do you want to participate in this? And we explained to them that half of them are going to have to wait a year. So some schools are going to start in year 1, some schools are going to start in year 2, and the ones that are waiting are the control group as we run this study. And the biggest set of those studies were conducted in the state of Texas. We were all over the state of Texas because equity and diversity were really important to us. And so not only were we running these studies in the Austin area or the Dallas-Fort Worth area, which are large cosmopolitan areas, but also in the very poor region along the border with Mexico. Almost everyone there is on free lunch, so they're very poor. Of course, Spanish is a predominant language here. We were also in very rural western Texas with the studies we talked about. And we've since taken these studies to Florida, and we're currently running the same study with successful results in London and the surrounds in England. That's what the picture is on the bottom. And at the top here, we have the results from these studies. And basically what you see is over and over again, we're able to measure a positive result. So the larger bars, in each case on the right, are the bars where they were using this integration of teacher professional development, a curricular workbook. And by the way, we have very strong data that actually doing the workbook was really important. Not just using the technology, but going through the workbook mattered. And we're comparing to the control. You'll notice that there's dark blue and light blue in those bars. We had 2 different measures. And I think that's important here. If you compare the dark blue, you'll see they're about even. Those dark blue is what Texas currently measures in 7th or, in the case of 8th grade, math on the TEX exam. On the TEX exam, there wasn't that much of a difference. The light blue is skills that came from other exams like PISA and NAEP and TIMSS that relate to preparation for algebra. And so you can see the effect that we measured was mostly on the preparation for algebra. If you only look narrowly at what the state of Texas cares about, or measures, they care about lots of things, but what they measure, you wouldn't have seen the big effect difference. And I think there's a huge important issue for us as we think about effectiveness here, is that we have to have the right measure. That if we're looking on a state test that doesn't measure the things we actually care about, we may put an intervention into a classroom and see absolutely nothing. And it's not because nothing happened. It's because we didn't measure it. So that's a really important issue to make sure the measures work. I actually much more like the graph at the bottom here. In that graph, this is a graph of the 7th grade experiment in Texas. And each bar there is one classroom. And the height of the bar is a learning gain. We tested kids before they used the 2 to 3 week long unit and after they use it. And this is, again, rate and proportionality we were looking at. And we measured the difference, and the difference is the height of the bar. So a taller bar is better. Green bars, we're using this package of resources. Gray bars, we're using their existing curriculum. And, well, what can you see right away? I think you can see the green bars are mostly to the right. The tall bars are mostly green ones. But there's much more interesting detail in this view of the data. One thing is do you see the 2 gray bars that are all the way to the right? Those are your superstar teachers. There are teachers out there that don't need technology, they don't need curriculum, they don't need anything. They're rock stars, and they can just go. And there's also 4 green bars over to the left. Who are they? Well, it's not always easy to make things work, right? And we had some examples where they're not getting improvements that are really, they're running in the middle of the pack. Nothing big is happening. And that is always the case with technology, too. But I think what's most interesting here is the clustering for the vast bulk of teachers in the middle, how helpful this approach was and how much more they were able to accomplish. And I think that's what we need to be heading for. Not just that a thing works in one place, or you can find one school or one set of teachers that are excited, but that when you take it out, this is around 100 classrooms, when you take it out to about 100 classrooms, for the majority of teachers and students, they're able to actually realize that benefit on the ground. And so it's robust. It works across settings, not just in special. I think that's what we need to look for. And this is one set of studies, but across a number of studies that we're doing. This is not going right now. Could you click me to the next slide? Because we got stuck. Thanks. Again, it's not that we gave them a pill. It's not that magic happened. It was this very careful integration of what's new in the technology, which was very much around these linking multiple representations idea, but a carefully laid out and orchestrated curricular workbook that guided the students and the teachers through how to do that over time in a classroom, and the teacher professional development all linked in. That's what we're finding is effective in classrooms. It's that integration. And so I'd really urge you, in thinking about your budgets, to make sure you're adequately budgeting for all three of those, and that you're not treating them as isolated buckets. Oh, we'll buy technology over here, we'll send teachers over there to some workshops that have nothing to do with the technology, and we'll buy a curriculum over here, and we'll drop them all into the classroom, and whoa, magic's going to happen. It doesn't work that way. This business of integration, in our studies, keeps showing up as crucially important. Still not clicking, so if you can go ahead one more for me. And one more. So here's some conclusions I'd like to remind you of. Again, I was trying to spread the beam. And so when you think about learning, I don't want you to think not just about individualized learning, not just about personalized learning, not just about linear, brick upon brick learning, but also collaborative, multi-representational, and connected learning. You need to broaden that picture. When you think about math in middle school, it's hard not to focus on algebra, but I'd like you also to consider that proportional reasoning may be a really important connective hub that ties together so much of the Common Core. And I love the calls today that we've heard over and over for the Common Core as an opportunity to rethink curriculum. I think it is a great opportunity to do that. But can we rethink curriculum not just as these isolated set of things that we've got to get through that one and we've got to get through that one too? And not just as this grid that puts geometry over here and data over here and algebra over there and that separates those topics. But when we rethink curriculum, can we think about the connectivity in the curriculum and how to build those clusters of powerful ideas? And finally, when you think about deploying or implementing technology, it's never going to just be this pill that you drop in and magic happens. Maybe with those superstar teachers, yeah. But we've got to get beyond that. We have to work with all of our teachers in our state. And that is really going to require this additional work that's really important of integration, integrating technology, curriculum, and teacher professional development. Well, thanks.